Yo, my friends, what is up? I hope everybody's having a splendid day. So today, I'm going to go through my process of refining jewelry, 14 karat gold. We're going to turn 14 karat gold into 24 karat gold. Now, 14 karat gold, what's 24, right? Half of 24 would be 12. So 14 karat gold is just a fraction higher. This is going to be our magic number. 14 karat gold is going to be 0.583. Okay? So this is the piece we're going to be working on today. It's a gold necklace that I got off eBay. It just has a few bends in it. There's nothing wrong with the gold or nothing. So we're going to be refining this. Here's how we get our magic numbers. First, we get a weight, and we know it's 14 gold. I already checked it and everything. Tested on the testing stone with 24 karat gold here. It is 14 karat. This weighs 4.3 grams. We take 4.3, multiply it by 0.583 grams times weight in gold, and it equals 2.50. We take 2.50, multiply it by 4, because we want to make an alloy that has 4 parts. 3 parts base metals, including silver, to 1 part gold. We're basically churning this into 6K. So we're dividing 24 karat by 4. So our number is 10 here. 10 minus the grams, the weight of gold, 4.3 is 5.7. So we need to add 5.7 grams of silver because I'm going to be using silver. I'm not going to be using copper or brass or nickel or anything. I'm using this silver that came out of my silver cell. So we're going to toss some silver up in here. We're going to tear the scale. And we're going to add 5.7 grams. There's 5.1. 5.3. That's a big one. Maybe save that. 5.4. 6. We'll take one little piece out. There we go. 5.7. Alright, so we're going to alloy this together. And we should be left with 10 grams. That'll be 1 point gold, or 1 part gold to the 4 parts total base metals. Let's make sure we got that right. Sometimes the scale gets a little funny, so 10.3. You know, that's fine. We'll leave a tiny bit extra. It doesn't hurt. Okay. We'll take one little tiny piece out. About that little guy. Okay, guys. I hope what I've explained makes sense. I'm not going to bother doing the testing. I already did that. Now, what I'm going to do is pull the steel spring out of this clasp, which doesn't weigh anything at all. And then we will alloy these together into one alloy material. Alright. So here we have the material in a crucible. And we're going to make an alloy. Now, when I do this, I also add a pinch of borax into my alloy. pinch of borax into the alloy. If you plan on doing this, make sure you have a graphite rod that you can stir the alloy with and make sure it's mixed up properly. Now we're going to melt this. Make sure you got a good mix. And then we're going to just go ahead and quench it. That's good. Alright. Now, we just poured it right in some tap water. You don't have to use distilled water for that, just tap water. Alright, we'll be right back. Okay, guys, so here's the alloy we are left with. That is essentially 6 karat gold. Also known as rose gold half the time. We have plenty of surface area in this shot. So when we go to extract the metal that we just put in, it'll be easy for that chemical reaction to happen because there's a lot of surface area. So what we're going to do is subject this material to hot dilute nitric acid. And we're going to boil it about 5 or 6 times in hot dilute nitric acid. What nitric acid will do is eat away this silver along with any other base metals that are still present in that gold, such as brass, copper, nickel, palladium, zinc, well, just anything that's in there. So through those dilute nitric acid boils, I'm going to retain my silver again. I'll be able to cement that back out of the solution and then run it through the silver cell. But I'll also be getting rid of any other traces of any other base metals. So that is why we have to alloy this to 6 carat if we want this process to work properly. So I don't have time to get into that tonight. It's a process. It takes a few hours. Each one's got to boil for however long until the solution is saturated and pregnant enough to cant off that liquid and then boil it again. It usually takes about 5 boils, maybe 6, all depending on how much you pull out of each boil. And I'll show you how to tell if there's still silver coming out of the gold or if you're all finished. Alright, we'll get on that tomorrow when I get home from work. But this is what your solution will look, or your material will look like. Rose gold, basically. Nothing pretty, but it'll work. That's how we want it to look. That's perfect. Alright, we'll get with y'all tomorrow and get this started. For now, I'll be back. Adios. Alright, y'all, what is up? We are back. Let me show you what I got going on. So, I only had about 100 milliliters left of nitric acid. What I did was put 100 milliliters of distilled water in here and put it in there and mixed it up. So now the stuff is boiling in the nitric acid mixed with distilled water. I'm using a little bit more distilled water than that and then adding this to it. The reason that liquid is blue is because it's pulling out base metals, meaning copper, brass, and whatever else may be mixed in with that gold along with the silver. If it was just silver coming out, it would be clear. So we're going to boil this about 3 or 4 times, pour it off, and that'll be that. Alright. This is our first nitric acid boil. And here we just have some used shot. Reason being, any unspent nitric acid in here can eat away at that before we cement out the pure silver out of this solution. We've got about 35 milliliters of that, what I mixed up. Straight on in. About 150 milliliters of water, and we're going to do it again. And we're going to do that however many times we need to until this liquid is clear. This reaction here will be done when the fumes stop coming out of solution. The reason you need to get that extra nitrate or nitric acid out of there is if you were go to cement the silver out of and there was nitric, the loop, and when the silver would cement out onto the copper, it would just go back into solution, create a bunch of sulfuric dioxide, and just eat away at the copper. So you don't want to create a loop for no reason and waste your shit. Alright, let's go through this one and we'll be back with the next one in a little bit. Alright, quick little update. This has been going on for a couple hours. When I look in here, I see something that looks like pieces of silver mixed in the alloy, but that I don't think are silver. It's really weird, because I'm used to doing this and I haven't seen anything like it. It kinda, I don't know, it kind of resembled kind of the silver crystals that come out of my silver cell, but they were shiny. So I'm not exactly sure what the hell that would be. When you introduce nitric acid to silver, it loses its shine and gets white like that, like a pasty milky white. So I'm not exactly sure what that is. So I put all that solution back in there with more nitric acid, and I'm gonna just keep letting it do what it does for probably another hour. I have only that much nitric left, about 6 or 7 milliliters. But I'm gonna wait for this to be clear, those fumes there, and then I'm gonna take it off the heat, take a look at the material, and then see where I want to go from there. Alright, we'll update y'all in a few. Alright, so check this out. We've got, this is that's the silver, the solution that I poured into the silver. So we know there's plenty of nitric acid in there. However, there was no reaction going on here at all whatsoever. But I swear, you cannot see it with the camera. Oh yeah, there's a little bit of shine. They look like, it looks like gold, bro. Like shiny gold. That is fucking crazy. No big deal. It will definitely come out during the refining process. Yeah, look at that. So there was a shitload of nitric acid still in solution, which means that is clearly done. And I'll figure out what's in there here in a minute. I'm going to set up the camera over here by the table and we will get started. Okay, we are back. Now we are going to dissolve this gold in AP solution. What that is hydrochloric acid and peroxide. I recommend you never buy this. You can use 3% peroxide up to 10% about safely. I would say 3 to 9 to be fair. Yeah, it would be very, very dangerous to use what I have there. And I say that because this is 40% and it is very, very, very reactive. I am going to make this into about 7%. So I'm going to add under 10 liters, or 10 milliliters, under 10 milliliters. And then I'm going to mix that with water. This is not a smart way to go about this. I was not paying attention when I bought the peroxide. But if you dilute it really well, supposedly it should be okay. So that's what we're gonna do here. Mind you, I'm going to be really slow with it. Okay, let us pray. What a stupid thing to do, huh? Alright, I'm definitely glove up and get ready to see what happens here. I mean, with the water, I don't know. I put a very tiny bit of hydrochloric acid. Hopefully there's not enough in there that'll cause any type of reaction to actually boil over the beaker. We are about to find out together. It's cold. Okay, I'm gonna set that on the heat for a little bit. It actually cleaned up the gold quite nice. I'm gonna set this on the heat plate, and we'll be back with a shot of that here in a second. Alright, we'll be right back. Okay, I think we lucked out. If I can get it to focus, yeah, you can see a reaction happening there. The heat is not up yet, just getting warm. Yep. Let me turn it down a little. We don't want it to get too warm. Now look at this. That's still going. It ate almost all that silver I had in there. So what I'm going to do is save this solution somewhere, and next time I need to dissolve some sterling or regular silver, I can use this solution first and then some more fresh nitric acid. Okay, once this gets a little more interesting, I will bring you back in for a close-up. Okay, so we still see a little fumes. There's like a couple crumbs in there, so obviously there's more nitric. So as I said, I'll be saving that. As we look in here, I added about 50 more milliliters of hydrochloric acid and about 1 more third of that peroxide solution I mixed up. We see it's clearly going in solution. Let's take a stannous chloride test real quick and just see what that looks like. Alright, here we go. Test it for stannous chloride and see if there's any gold in solution yet. Alright, let's get that on camera. Yep, we're getting a black stain, which would indicate gold in solution. So we're getting the job done. I'm gonna let that go for however long it takes. Probably another half an hour or so, I would guess. If the reaction dies down, I'll add a tiny bit more of that peroxide solution. But I think we're gonna be good. That got pretty dark pretty quick. And well, that makes it so you can't see it, but I can see it a little better. Yeah, I'm not seeing any other PGMs in there, which would be platinum group metals. I don't see any green or orange or any of that. Just the dark purple, blackish for gold. So we're in business. All right, we'll flick the camera back around. when we get closer to the finishing point of this here gold. Alrighty. Okay, it's only been about 5 minutes. Five to 10, give or take. And we are about 2/3 of the way done. So, doing it this way, instead of using aqua regia is hydrochloric acid and nitric acid. The fumes that it produces, like this jar here, they are toxic, they are poisonous, and extremely corrosive. All your metal will start to rust away if you do this anywhere near metal. Plus, you don't want to be breathing it in. Like I said, it's toxic, poisonous, and very corrosive. Doing it this way, you're only using hydrogen peroxide. It's perfectly fine. And on top of that, you do not have to denox your solution for leftover nitric acid. When you do aqua regia, you need to make sure all the nitric acid is consumed before moving on, or else you will not be able to precipitate out the gold when you're ready to do so. Sorry, I'm having hiccups. So this way is cleaner, extremely less expensive, and produces less waste. All around, it's just better. I prefer it. I only use my nitric acid for silver now. I do all my gold with peroxide. You do you, though. Some people like using nitric acid because it sounds cool and it looks cool, but I guarantee you it's not as cool. You're hitting your pocketbook. You got bad fumes you need to deal with. If you're not in a well-ventilated area, you need to have a fume hood to pull those fumes away from you and away from your equipment. This way, in my opinion, is much better. So I'm gonna wait maybe 10 more minutes and I'll come back and take a look. Alright, see you then. Alright, y'all, we are back. So that took a lot longer than I previously stated. I don't know why it slipped my mind, but when doing peroxide, if you don't have a delivery system that's constantly feeding the solution more peroxide, it slows down and halts. So you always got to be adding a little more. It's time consuming. I forgot about that just because I'm so fucking tired. So what we're going to do now is filter this. I had already put in some distilled ice cubes. Ice cubes made out of distilled water. If I would have used nitric acid, then I would denox the solution with some sulfuric acid. I'll just put a few crystals in there until the bubbles stopped. And now we will add sulfuric acid. If you have any questions about what's what, just holler at me. You gotta be very careful with this. Alright. Now what that'll do is precipitate out any lead that might have been present in that solution. So we'll just mix it up. I have a feeling there might be a few granules left of the gold. Not a big deal, we'll get that out later. Out of the filter when I process these filters. So now I'm just going to filter this a couple times. It looks pretty damn good as it is, though, to be fair. So all in all, getting the gold into solution took closer to, I would say, 3 to 4 hours in that time frame. Yeah, there's a couple tiny granules left. Perfectly fine by me. I'll recover that later when I process my filters. Alright, I'm gonna filter this a couple more times and we'll be right back to the next part. Alright, y'all, so we've been at this all day, and this is now the moment of truth when the magic happens. The gold is now refined, mind you, only once. We will double refine it again tomorrow. First, we want to get our stannous chloride test. Make sure it has the presence of gold in the solution, and we didn't do something really funky and lose all the fucking gold. That would be horrible. Alright. We've got purple. Darkish purple brownish. So positive for gold. Alright. Now we use a chemical known as sodium metabisulfite, aka stump out. I showed it in another video. We add the chemical and there will be a reaction. Now mind you, this produces nasty fumes, so you either want to be in a ventilated area or have a fume hood. Alright. Mix that up a little. I'll even go ahead and use the stirring rod. And we will quickly do another stannous test. Yep, there goes them fumes. And see if all the gold is out or if we need to add a little more SMB. I'm not getting any color on that. So that would indicate that all the gold has now dropped out of solution. Not going to be able to see it for a while. But what we will do is just let that settle out overnight. And then all the gold will be at the bottom and the solution will be clear at that point. Yep, we got white foam. Alright. So tomorrow we will pick up the process and continue. I am done for the night. I'm fucking tired. And I will catch y'all on the flip. Okay, y'all, it is the next morning. It's settled out real nicely in the beaker. What I've done is a series of boils. I've explained in the last video what I do to clean. So we do a few boils of distilled water. I do a boil of hydrochloric acid, then water again, and then I use ammonia. Do a boil, and then I boil it in after the ammonia, I use distilled water a couple more times. So that's what we are left with. Some pure, beautiful gold. I'm going to melt that into a button real quick, and then we will take a look at it and get a weight. Alright. Okay guys, here we have it, the moment of truth. That's the one we just boiled up. Boiled. That's the one we just melted. So, if you remember, we started at 4.3. 4.3 grams of 14 karat. And we are left with 2.6 grams of 24 karat. Now, it doesn't look as shiny as this one yet. I will double refine that. But I also boil everything in sulfuric acid, I'm sorry, and that'll take care of the flux on top and anything else. So now we're sitting at 8.3 grams 8.3 grams of 24 karat gold, and I'll double refine and triple refine this one. This one's been double refined already, and we'll do all that on a future video when we have more material. I say when I get up to at least half of a troy ounce, which would be 15 grams. No, that'll be a little too low. Let's wait till we have 1 full troy ounce, and we'll do a whole nother video with a bigger batch, and you can see that process. So there we go. I hope this helped anybody. Feel free to ask questions, and I'll do what I can to help. So 8.4 is what we're sitting at. Alright, cool beans, man. That's going to be the end of that one. Any questions, feel free to drop them in the comments. We'll catch you on the next one.